the equivalent resistance between terminals X and Y of the network shown is, okay. So this is one of the previous year question only. So not only in SSC JEE, even in the engineering services exam and even in the GENCO TRANSCO, all these exams also, this model of questions are common, okay. So this model of circuit questions, okay. So the equivalent resistance between terminals X and Y of the network shown, okay. So they have given between the X and Y, okay. So immediately whenever you see this model of questions, okay, so there is something we have to remember. Between these two terminals we need resistance. Between the other two terminals some other resistance is connected, okay. It may be bridge connection, okay. We have to check first it is a bridge connection or not, okay. So what is a bridge connection means? Between two terminals, okay, so between two terminals the source must be connected, okay. Source must be connected, otherwise you want resistance from these two. Understanding right? You want resistance from these two, otherwise the source must be connected between these two, okay. And between the other two terminals some load has been connected, okay. So this is the load, otherwise some resistance is connected, otherwise there may be some short circuit also, there is no problem, okay. If any short circuit present, this is all bridge connections only, okay. What is a bridge connection? Between two terminals source must be connected, otherwise we want resistance, okay. And between other two terminals there must be a short circuit or resistance is connected or some load is connected, okay. So that is the one bridge connection, okay. It is the same thing, we want resistance between these two terminals, between other two terminals we have the resistance, okay. Now whenever it is like this, whenever it is a bridge connection, check like this, okay. So R1, R4, R2, R3, okay. So what is the balanced bridge? Whenever R1 into R4 is equals to R2 into R3, okay. So R1 into R4 is equals to R2 into R3, then the bridge is balanced, okay. So balanced. What is the meaning of balanced? So how much current is going like this? Same current will definitely come here. Understanding right? How much current will flow, whether bridge is balanced or unbalanced, definitely same current will come here. But whenever bridge is balanced means how much current is going in this, same current also in this one. Got it right? Similarly, how much current is going in this one, same current will flow in this one. This is the bridge connection, okay. So that means what is the current going? For example, 5 amperes current is going like this means same 5 amperes is coming. So what is the current going in this one? According to KCL, if 5 amperes is coming like this, 5 amperes is leaving, 0 amperes must leave here, okay. So that is the bridge analysis, okay. So whenever bridge is balanced means what is the current in the middle element? That will be equal to 0, okay. So that is the balanced bridge connection, okay. So whenever bridge is balanced, the current in the middle element, whether it is a short circuit or a resistance or some other element, anything, okay. So current in this one it will be 0 only whenever bridge is balanced. What is the balanced condition? R1 into R4, you should not multiply like this, okay. R1 into R3, otherwise whatever resistance is you should not multiply these two, okay. So opposite ones, okay. So opposite ones you have to multiply, okay. R1 into R4 is equals to R2 into R3 means definitely so bridge is balanced, okay. Now we have to check this here, okay. So here 5 into 30, okay. So what is 5 into 30? So it will be 150 is equals to, okay, 15 into 10, that is also 150 only. So it is correct only. So bridge is balanced. So what is the current going inside? That will be equal to 0. Understanding right? Current going inside is equals to 0 means how current equal to 0? Where current equal to 0? So current is not flowing at all means whatever element it is, current is 0 inside, okay. So current equal to 0 means whether it is a short circuit or open circuit, current equal to 0. No current is flowing means it must be open circuit. In open circuit only no current will flow. If short circuit means high current, okay. So we have to replace this element by a open circuit. Whenever bridge is balanced, whatever element is there, short circuit, resistance or any of the load is there, we have to open circuit this one, okay. So if you open circuit, then the circuit will become like this. This is the 5 ohms and here it is 15 ohms and here it is 10 ohms and next element, okay. So here it is 30 ohms. So we want resistance between these two, okay. So this is X, this is Y, okay. Now these two are connected in series, okay. So there will be some element but virtually no current is flowing here, okay. No need to draw it again, okay. Directly 15 plus 5 is nothing but 20, okay. So because of these two, 20 ohms equivalent you will get. Because of these two, 40 ohms equivalent you will get. Okay. So now 20 in parallel with 40, what you will get? 20 into 40 divided by 20 plus 40 is nothing but 60. Okay. So 21s and 23s it is. Okay. So directly 40 divided by 3 you will get. Okay. Answer is B for this one. Okay. So this model of questions again. So even though some students will consider, for example, here short circuit is there, for example, still no current is flowing. Okay. Same question only. See, if for example short circuit is there, if the bridge is balanced means we have to consider whatever it is a open circuit only. Okay, like that. Okay. See the next question. 3 resistances 5 ohms each are connected in star. Values of equivalent delta resistances are. Okay, so this is one of the common questions they used to ask in the GENCO TRANSCO exams. Okay, so one of the common questions this model. Okay, so 3 resistances of 5 ohms they have mentioned. This is 5 ohm, this is also 5 ohm, this is also 5 ohm. Okay, so 5 ohm, 5 ohm, 5 ohm are connected in star connection. Okay, they are asking equivalent delta connected resistance values. Okay, what are those values? Okay, delta connected values. See, whenever star given, okay, so we have to convert into delta connection means only one formula we have to use. Okay, so that is nothing but R1 R2 plus R2 R3 plus R3 R1 divided by okay, whatever is there opposite. Okay, so generally we have to use that. Understanding, right? Star to delta we have to use. Okay, generally delta to star everyone will remember. Okay, so like for example here RA is there, here RB is there, RA RB. Okay, so this is RC for example. If here you want resistance means RA RB divided by RA plus RB plus RC. Directly we can remember that. Okay, understanding, right? So now what you have to do, for example you want resistance here, for example this is star to delta. Okay, if you want to calculate from star to delta, you want resistance here means whatever is there. Okay, so for example this is R1 R2 R3. Okay, so if you want resistance here, so it will be R1 R2 plus R2 R3 plus R3 R1 divided by, numerator will be same wherever it is, this resistance or this resistance or this resistance. Okay, numerator will be same only. R1 R2 plus R2 R3 plus R3 R1 divided by, you want resistance here, right? Opposite, what is there? R2 is there, divided by R2. That's it. If you want resistance here, what is the value? R1 R2, numerator is same only. Okay, so R2 R3 plus R3 R1 divided by whatever is opposite, we have to use that, divided by R3. If you want here, okay, so numerator will be same only. What is the denominator? R1 is the denominator. Okay, so anyway, just for understanding only I have given, so directly we can solve this one. Okay, so 5 ohms, 5 ohms, 5 ohms. Okay, if you substitute in this one, whatever it is same you will get, because all the 3 resistances of value 5 ohms only. Okay, so 5 into 5. Okay, so 25 plus 25 divided by 5. Okay, so 75 divided by 5 you will get. Okay, so what is the answer for this? 25 will be the answer. 25 ohms. Okay, so 25 ohms it is. Okay, so they are asking values of equivalent delta resistance they are asking. Okay, so option is not present. Okay, so delta connection you will get a higher value, that is 25 ohms you will get. Okay, so for example the same resistances if they have given in star connection, okay, so we will consider in a they have connected in delta first and we will try to convert into so star connection. Okay, so this is 5 ohms, 5 ohms and 5 ohms. Okay, so 5 ohms, 5 ohms and 5 ohms. If you want some resistance here, okay, so resistance 5 into 5. Okay, so 25 divided by 5 plus 5 plus 5, 5 plus 5 plus 5. Okay, so directly 25 divided by 15 you will get. So then 5 3s and 5 5s. Okay, so 5 by 3, so is nothing but so 1.33 you will get. Okay, so 5 by 3, so this is the option in that way. Okay, so maybe they have confused while giving the question. Okay, so they have connected in star now and they are converting into delta, so you will get values of 25 25 25. Okay, so that is the answer for that. Okay, now if you convert into delta to star, it is 5 by 3. Okay, so now remember some things. Okay, whenever you are converting star to delta, okay, so values will increase definitely. Okay, so star connection to delta connection, if you are transforming like this, okay, so then definitely values, okay, higher values will come, okay, higher values. Whenever delta to star we are converting, okay, so delta to star we are converting, all the values will decrease definitely, okay. If you want, you can check once, okay, just check once, so you will understand, okay. Take 3 ohms, 3 ohms, 3 ohms, you will get, okay. Otherwise, if all the 3 are in delta connection, okay, so 3 ohms, 3 ohms, 3 ohms, okay. 3 into 3 is nothing but 9. 9 divided by 9 is nothing but 1 ohm, 1 ohm, 1 ohm you will get, okay. So these are in delta to star connection. But similarly, okay, so if 3 ohms, 3 ohms, 3 ohms are there, if you convert like this, you will get 9, 9, 9, okay. So just check once, okay, on your practice, you will understand, okay. Next question. The nodal analysis is primarily based on the application of, okay, so nodal analysis is application of what they are asking, okay. So nodal analysis at a node, okay, so nodal analysis means at a node we have to consider, okay, so nodal analysis at a node we are doing. At a node what you can write down? At a node what you can write down, KVL or KCL? At any node or junction, okay, so at any node or junction, algebraic sum of the currents is equals to 0. Okay, otherwise incoming current is equals to outgoing current, okay. At a node you cannot write down the voltages, all the voltages, okay. So you can write down all the currents, whatever branches are connected, for that all the currents we can write down, okay. So that is the, so nodal analysis at a node we are doing. So at a node what is the thing? KCL we can write down, first one. But directly in a nodal analysis, directly you don't write down the currents, okay. How we will write down the currents? By assuming the node voltages VA minus V1 minus 0 divided by R1 like this, okay. In the previous some question we have already seen. Plus, okay, some other current like that we used to do, okay. That means the voltage equation, this is the current equation only, okay. First current plus a second current plus third current, all the currents is equals to 0, like that we used to do. Understanding, right? That means this is current only, but directly we are not using. How we are writing? Voltage divided by resistance. This is the voltage, this is the resistance. Voltage divided by resistance we are writing. That means we are writing KCL equation only, but we are using Ohm's law. What is Ohm's law? So current is equals to voltage by resistance we are using. That is nothing but Ohm's law. So nodal analysis is the combination of, okay, so nodal analysis is the combination of KCL and Ohm's law. Okay, KCL and Ohm's law. Okay, this is the answer. Okay, so nodal analysis. Similarly, mesh analysis. Mesh analysis means we will write down the mesh equations. Mesh equation is nothing but KVL equation, okay. So mesh equation is nothing but KVL equation, but directly will not write down, okay. Just think once, okay. Current into resistance you used to write down, okay. That means KVL plus Ohm's law, okay. So KVL plus Ohm's law. This is the mesh analysis, okay. Now what they are asking, the nodal analysis is primarily based on application of Kirchhoff's current law, Kirchhoff's voltage law is cancelled, okay. Ohm's law, Kirchhoff's current law. Option D is correct one, okay.